Hello and welcome to another LeetCode solution. In the last solution, I realized I forgot to up the screen size. That was my bad. But on this one, we're going through another code solution. Again, just a disclaimer before I get started. This is by no means the fastest, the most space efficient. This is just what I deem an easy to understand approach for beginners, because that's what this is targeted for, I should say, is more beginners and people trying to do these easy problems, maybe for the first or second time, or I want a quick refresher on how to approach it. If you want to make it better, go for it. I'm just going to show you my quick and dirty approach I had in the first place that also works. So to get started here, let's go ahead and read the problem. You're given the heads of two sorted linked lists, list 1 and list 2. So we already know that both of these are both of our lists here are, what do you call it, sorted. So we got to merge the two lists into one sorted list. This list should be made by splicing together nodes of the first two lists. Return the head of the merged linked list. For example, one here we have 1, 2, 4, 1, 3, 4. It should be 1, 1, 2, 3, 4, 4. So there's no need to skip numbers or anything. Have them all there in the list. And then two empty lists should give you an empty one. If one's empty and one has something, it should output whatever that one thing has. So numbers in the nodes range from 0 to 50. Or sorry, number of nodes in both lists will be from 0 to 50, and the value can be from negative 100 to 100. Both are sorted in non-decreasing order. So they're all going to show up kind of like this. Whether they have negatives or not, I'm not totally sure. But let's stop yapping and actually get into coding here. The first thing that I thought to do here is to create a new list node. So we get new list node. We can just call it like node or something, whatever you want to call it, equals new list node. And then up here, you also have the definition and the comment here. I didn't make this. LeetCode automatically supplies you with this. It kind of shows you what list node is like, and this will be a good way to show you guys how to interact with classes that are already defined in a LeetCode comment like this. The next thing we're gonna do here is we're gonna do a list node equals node, and you'll see why we do this in a little bit here. And then we're going to want two things here. We're going to want the int temp to equal integer dot max. If I could spell, that'd be fantastic. Max value. We're also going to want a num1 equal to not all caps here. Integer. I cannot type right now. Dot max value, because we're going to compare two things here. Then we're going to want num2 equal to, again, you guessed it, integer max value. There we go. So now we have three integers here. We have a temp, a num1, and a num2 here. So that's all well and good. And next thing we're going to want to do here is create a while loop. I usually try to avoid while loops, but in this case, it does make sense to use it. So we're going to do while list 1 doesn't equal null, or list 2 doesn't equal null. We're going to go ahead and loop through this here. So we're going to do here is do an if check. We'll do if list 1 doesn't equal null. Again, since we did an or here, at any given point, one of these could be null and we would still enter into this loop. So we still need to do a null check here. And then we come down here and do another if check. So if list 2 doesn't equal null, we can go through here. And you don't want to do an else if here or an else statement. That's just because you never know which one it's going to be. So like, just like if this isn't null and then you do else if, you would just skip the null check for list 2 and then you wouldn't get it. Or if list 1 isn't null, or let's say list 1 is null, I guess you could check it, but I'm just doing it this way. I feel like I'm confusing people more by the more I talk. So what we'll do here is we'll set num1 equal to list 1 dot value, or it's dot val in this case. You see here it describes it as val, and then here same thing. We'll do num2 equals list 2 dot val. In this case, after this, we'll take our temp number and have it equal to math dot min of these two. So we'll do num1, num2, just like so. So in this case, we have the lowest number here. You can call it temp. You can call it whatever you want. You call it like lowest value. I'm just calling it temp just because. So in here we want to do something here. So if temp equals num1, then we do an else statement here, because if it doesn't equal num1, it's going to equal num2. There's no reason to do another if check here. Sorry, I had to cut the recording there for a second. Just my throat is bothering me. So here we do here is, so if temp equals 1, we can do something like this. So once it comes here, we want to increment the list1 to the we'll do list1 equals list1 dot next. And then from there we can do reset the num1 equal to integer dot max, all caps, max value. And the reason we're resetting it here is because let's say list1 equals list1 dot next. Then let's say list1 is now null after this. If we don't increment it here, list1 here, and set this to max value, this num1 will always be lower than num2, because list1 is null, so it's never getting reset again, in which case you'd end up in an infinite loop, which is why we need to set to max value. Okay, my throat, dude. So anyway, and here, so if temp equals num1, we increment list1. If it doesn't, we need to take list2 equals list2 dot next. If I could spell, I'm struggling today. And then again, same thing here. Same logic applies. It's integer dot max value. Because again, it could be the other way around. It could be like list2 is now null. Therefore, we'd end up in a infinite death loop there. And then from there, we can do our cur. So if you remember, we set cur up here. So we need to do this cur. So cur dot next equals new list node. And as you can see here, there's a list node constructor where we can set the value here. There's also another constructor where we can set the value and the next node, but I don't really need to do that. So next node, and then we will set that equal to the temp number. And then we will increment this one to cur dot next, now that we created our next node. And that really pretty much completes our while loop. And then from there, we can go down here and we can say return node dot next. Or not the method here, but the reason we're doing node dot next is because this is our initial thing. So this is still holding the head of our list node of our list. You can think of it, it's like a linked list, single. I cannot talk today. I should just not record this, to be honest. We have a singly linked list here, and this is still pointing to the head. So let's return the next node, because if you remember here, in the first case, we're setting the next node equal to the first thing we found, and then going from there. So from here, we just want to return node.next, and it will return the entire list. So if we go ahead and run this, let's see. Oh, I forgot to say list1. Try it again. I think I saw it down here too. I see it down here. Did I do it anywhere else? Math.min. I don't think that's capitalized. There we go. Yeah, so now we have our test cases pass. It does it as we expect. So 1, 2, 4, 1, 3, 4, 1, 1, 2, 3, 4, 4, just like in the examples here. And all the examples are the same, showing that it works. And if we go ahead and submit this, pending. It's actually the best runtime you can get, so 0 milliseconds. I'm up here with everyone else. But the memory, not so much. The memory could be a little bit better. But yeah, that's pretty much it for this. If you guys are learning Java and want to learn it more, I do have links in the description. There are links in the description just in general. We have a link to the problem and a course that I have on Udemy where it teaches beginners how to code in Java. It's a very quick, efficient course. I think it's less than like 7 hours, and you should be pretty good to go. Honestly, it's a very, very solid foundation. I won't go into all the specifics here, but yeah, if you guys are interested in that or friends interested, family, go ahead and use that link in the description. It does have a referral code. It pretty much stops Udemy from taking a majority of it. It's pretty much all. But yeah, I'll stop you at this point. Leave comments, questions, concerns in the comments below. Check out the links, and I'll see y'all in the next one.